Welcome to another video on graphing functions using transformations. For this problem, we'll be using the 4 points that are provided on the graph of the parent function to apply the transformations. -4 followed by 2, -2 followed by -2, 0 followed by -2, and 6 followed by 2. To graph the equation y1, which is defined as f of -x, this indicates that there's a reflection about the y-axis, which means that we're going to negate all the x values or the x coordinates of the points on the graph of the parent function. So here we have -4 followed by 2. The x value is a -4. So negating that becomes a +4, which now transform that point along the y-axis. So let's use the star to indicate that new point. We will now do the same to the remaining 3 points. Using -2 followed by -2, we're going to reflect that along the y-axis. In other words, negating the x value. So here's our second point. Notice that these are basically points that are connected in terms of segments. So point 1 is connected to point 2. Point 2 is connected to point 3 in a line segment, and point 3 is connected to point 4 in a line segment as well. So I'll start connecting 2 points at a time. Okay, now point 3, reflecting this about the y-axis, it's going to remain there since the x value is 0. And now point 2 is connected to point 3. And finally, our fourth point, 6 followed by 2, the x value is 6. We're going to negate that, which now gives us -6 followed by 2. And again, point 3 is connected to point number 4. And there it is, the graph of the equation y, which is f of -x. For our next one, the equation y is defined as f of x plus 4. This simply means that it's a vertical shift of 4 units up. So every point on the graph of the parent function is translated 4 units up. So this one goes up as well. This one, now our last one, 4 units up. And now using those 4 points, we're simply going to connect the dots together with segments. So same shape as the graph of the parent function. The shape is not distorted at all. And there is a graph of y. For letter C, y is defined as 2 times f of x. This 2 means that there's a stretch of 2 units vertically. So we say it's a stretch of 2 units by a factor of 2, which means that all the y values, all the y coordinates of the points on the parent function are being multiplied by the constant 2. So looking at our first point, the y value there's 2. We're going to double that. So we don't change the x coordinate at all. So doubling the 2 gives us a 4. So that means the point -4 followed by 2 is now -4 followed by 4. So we're stretching it out. This point here is -2 followed by -2. So the y value is -2. Multiplying that by the constant 2 changes its y value to -4. So this gets stretched out vertically. Same as our third point, And now our final point, the y value is 2, stretch that out by a factor of 2. So now with our new 4 points, just like before, we're going to connect those dots together using line segments. And that's the graph of the equation y. On letter D, we have two transformations. We'll start with the one inside the parentheses. Quantity x minus 4 means that there's a shift of 4 units to the right. And then the negative in front of the function is a reflection along the x-axis. So using the same 4 points, shift 4 units to the right, which is now at 0, 2. Now we're going to flip that along the x-axis. So the first point is now at 0 followed by negative 2. So I'll just indicate that as first, just so that I can keep track of them. Our next point, 4 units to the right. So 4 units to the right, it's now at 2, negative 2. Flip that along the x-axis. So here's our second point. And then our third one is at 0, negative 2. So 4 units to the right. Flip that along the x-axis. And now that's our third point. Finally, the last one, 4 units to the right. And now flip that along the x-axis. It's now at 10 followed by negative 2. Okay, so this is our fourth one. So first dot connected to the second dot. Second to the third. And then the third one to the fourth. And that is the graph of the equation y. Letter E, we have f of x minus 3. So I'm going to skip this one. This simply means shift of 3 units down. So every point on the parent curve is shifted down by 3. Letter F, the function f of x times negative 1. So that means reflect the x-axis and then shift the graph down by 1. So reflect along the x-axis and then down by 1. There's our first point. Reflect along the x-axis and then down by 1. There's our second one. Same thing on the third. Reflect along the x-axis, down by 1. That's our third. And our fourth. Reflect along the x-axis and then down by 1. Okay, so now connect them. And there's the graph of the equation defined on part F. On part G, we have y is defined as f of 2 times x. So this is equivalent to saying y is equal to f of c times x, where the constant c here is 2. So whenever we stretch or compress in the horizontal direction, we multiply the x value by the reciprocal of c. So the reciprocal of c, which is 1 over c, is 1/2. That means we're going to compress the graph horizontally by 1/2. In other words, we're going to multiply all the x values by 1/2. And so using our first point here, the x value is negative 4. Half of negative 4 is negative 2. This point or the curve is getting compressed pushed in, that is, by a factor of 1/2. So it should look more narrow compared to the graph of the parent function. Same here, the x-coordinate is -2 times that by 1/2. That becomes -1. This point here, the x value there is 0. Remember, 0 followed by -2. So the x-coordinate is 0. 0 times 1/2 is going to remain at 0. So that stays there. And then our last point, the x value is 6. Half of 6 is 3. So this gets pressed and compressed by half. And now with the 4 points, similar to the other parts, we're going to connect them with line segments. As you can see here, the graph of the equation y is more narrow compared to the graph of the parent function.